also I'm trying to get another perspective on APIs. I think it's an interesting thing. I don't even know what it is.
You've seen it around the internet, so awesome. Thanks for being here.
I'm Markel, and just same thing, trying to figure out what GraphQL is, because I see a lot of different tutorials on YouTube, so I haven't had a chance to learn it, so this is for Mark.
Right on. Markel came here from San Antonio to be here tonight, so we got some travelers too. And then I didn't catch your name before.
I'm Andrew.
Andrew, cool. Thanks for being here. And we had one more person come. Did you just arrive? Yeah. What's your name?
My name is Chong.
Chung? Cool. And what are you here to gain?
I'm going to try to utilize GraphQL for my new project. So.
New project? A side project of your own?
No, it's a company.
At the company. Very cool. Well, hopefully we can help with that. So my name is Dan. Dan Cumming. I'm the Director of Partnerships at Austin Coding Academy. We're a nighttime coding school focused on web development, and we teach classes right here in Capital Factory. For those of you that are already developers, if in any way you'd like to partner with a coding school, if you're looking for talent, we have a lot of graduates and alumni that are a year or two into the business. If you're an aspiring coder, there's different levels of coding classes that we offer. So if you're curious about that at all, just grab me afterwards and we can chat about that. But what this meetup is it's the ACA Developer Series. So we teach a different topic every single month. This is the second Wednesday of each month. Last month we taught TypeScript. We've taught Selenium testing. We've taught, I think coming up at some point we're going to be doing AMP, as in AMP compliance, if anybody's heard of that. And then Ivo is a former instructor of ours, and now he's got his startup called SlickNode, and he's agreed to teach us about GraphQL today. So I'm gonna let you take it away.
Awesome.
Let's learn.
Yeah, thanks everyone for coming out here. My name is Ivo Meissner. I'm from Germany, and I live in Austin, Texas now. And I've been in software development for I don't know even how long, like 18 years. I kind of got bored, like doing the same thing over and over, like loading data, transforming it, validation, and like building APIs, etc. And like when Facebook open sourced GraphQL in 2015, I thought like, oh, this is an awesome technology which you can use to automate a lot of the grunt work that I used to do. And I started playing with it. So like first I was working on a project in PHP. I ported then the relay library that Facebook open sourced to PHP. Yeah, I've been working for GraphQL ever since. Like I've transformed like one bigger project. It was like started in 2004, the code base, like transitioned that to GraphQL. It's an awesome thing. It's a lot of fun, and it's actually not that difficult. So like, I hope if everyone goes out here after the workshop, you have an understanding of like what GraphQL is, how you can use it, and why it's so good in like in a particular use case and very broad array of use cases. So let's get started with a little. Okay, so let's first do a little introduction of GraphQL. So we'll do some general knowledge about GraphQL, what it is, why you want to use that, how does it compare to REST, how is it better. Let's get started. So what is GraphQL? So GraphQL is simply just a query language for your API. That's it. There's a lot of misconception. People say like, oh, it's a database, it's a graph database, it's like a server language. No, it's not. It's simply just like a protocol specification, a query language for your API. We're going to see what that looks like in a little bit. So it was developed in 2012 at Facebook to power mobile applications. So they put like a lot of research and development in there to solve the problems they had with mobile applications. So it is a technology that scales, especially in terms of complexity. If Facebook can use it, it's probably going to be big enough for your project. Then in 2015, they open sourced that. They like open sourced one server implementation. It's a reference implementation in JavaScript that's still widely used right now. I think it's like the most popular one. But it's not particularly tied to Node.js. There's in almost every programming language there's a GraphQL server implementation. So like whatever your stack is, you can probably use, you can implement the GraphQL. You just have to implement the query language, and then you can use GraphQL with it, since it's just a specification. And then in 2018 it was handed over to the Linux Foundation, so it's not proprietary managed by Facebook anymore. It's like part of the Linux Foundation. So like it's a technology that a lot of big companies bet on. Let's take a look. So who uses GraphQL? Is it just a niche thing that like Facebook does? And turns out there's a ton of companies that use GraphQL. It's Twitter, Yelp, GitHub, Intuit, Facebook, of course, Pinterest, Shopify, Atlassian, PayPal, etc. And more companies are adopting that. Like since you all said, like there's more and more demand of companies that need, they want to transition to GraphQL and use that. And you'll probably see why when we take a closer look to that. So let's see, why GraphQL? Facebook developed this to address the shortcomings of REST APIs. There's like certain issues you have with REST APIs. We'll look at this in detail a little bit. Basically, it allows you to have the functionality of your entire organization accessible via one GraphQL endpoint. So you don't have like 500 different REST endpoints that somehow need to be documented. You have like all the functionality that's available or that you want to make available in one central place of your organization that everyone can use and everyone can talk to. So that dramatically simplifies things. Another thing is it decouples the front end from the back end development. So you can develop the back end entirely from the front end. Well, you can say you can do that with REST APIs anyways, but you still have to do a lot of communication. You have to say like, in the front end, I have this new requirement, I want to show like a teaser here. Then you have to talk to the backend developer. Say like here, how can you expose that via this API endpoint, make the change. So there's like a lot of dependencies between the front end and the back end that requires communication with REST APIs. And with GraphQL, you just expose all the functionality, and then that's it. You just like, as a front-end developer, you can just use that functionality as it fits for your application. Another big thing for Facebook was you can evolve APIs at scale without versioning. So Facebook had like hundreds of different clients out there. For all the mobile versions that people don't upgrade, they had web clients, they had desktop applications, you name it. And to evolve those APIs is really difficult. Like to say you want to add something, but like you don't want to push it to like the old clients that don't need it. Or if you want to remove something, so like you want to deprecate a field, you can't just like deploy a new version. So like you have an endless amount of REST API endpoints on versions, which becomes unmanageable, especially if you build something at scale. So this is like one of the biggest issues that GraphQL solves. Let's have a look at a traditional REST API. So usually it looks something like that, as just like a simple example. You send one request to a certain resource, let's say here product 234, and then you get predefined response. So like if you call this endpoint, you get this particular response with this data. And that's it. If you're lucky, it's documented. It might not. You might get a result sometimes, sometimes not, depending on what the server responds. So yeah, this is one challenge. Another challenge is like if you call this resource here, let's say product 234, it usually has like other entities that are related to it. For example, this product has a category. And if you call this API endpoint, you either can decide like, do you put the whole response of that category into the response entirely, which you might load then on one page and not need it, or like do you put a URL in it and then you have to have in the front end develop all this API fetching logic, etc. So this is a challenge that you have with REST API endpoints, which GraphQL addresses. Common issues, overfetching, so you might get too much data, more data than you actually need. There was also one of the big reasons that developed this for mobile applications where bandwidth is like really expensive. They wanted to load the minimal amount of data. So like for mobile applications, it's really good because you can only get that data that you need. Or underfetching, as we've seen with the category URL, you might get like just a reference, and then you have to make another round trip to the server, including all the loading, error states, etc. You might have unknown return data. So like REST API is usually not typed, so you might get like a string, maybe you get a null, maybe the field is missing, things like that. You all have to handle all that in the front end, or oftentimes just crashes. Lack of documentation. I think everyone who's worked with a couple of APIs knows that good documentation is scarce, and oftentimes it's out of date. And one big point is that results in complex front-end logic, where you have to combine all that data from all your REST API endpoints, display it, handle the loading states, handle the error states, handle the authentication, all this stuff. So like this is the burden of the front-end developer that you have to implement all this. Then you have countless dedicated endpoints. You always have to figure out, oh, like what's the URL, how are the parameters passed, this kind of stuff. And then if you have API changes, how do you do versioning? How do you do deprecation? Those are all big challenges for REST APIs, especially if the project becomes mature and you want to upgrade it and keep evolving it. So let's see what this whole thing looks with GraphQL. So with GraphQL, it puts the power into the hands of the front-end developer. So what you see here is a GraphQL query. You have your application, it can be a mobile device, can be a website, your client application, and then you send it a GraphQL query to the server, and then the server automatically resolves loads the data from all the data sources. It could be multiple different databases, etc. Compiles the response exactly in the format that you asked for, and you get a predictable result. This is all the magic. So like if you want to make a change, you just add a field, you get a different response, and you get exactly the result that you asked for. So this is pretty awesome. You don't have to create a new REST endpoint. You don't have to do multiple calls to the API. You can just define here, this is the data I need for this view, and it just fetches this automatically. And you can integrate that into client libraries really easily. So let's take a look at it, and if you want, you can also go to that URL. It's like an unofficial GraphQL API from SpaceX with like all the SpaceX data. Let's open this up and let's explore a little bit. So is it visible? Damn.
Can you zoom in a bit more?
Yeah, try. But better?
Yes.
All right. So let's take a look. Let's make this. Let's clear this and let's start from scratch. So a GraphQL server is it usually is exposed via HTTP, but can also be WebSockets or any other protocol. It's really flexible, but like GraphQL doesn't specify that. But most of the time, you have like an HTTP server where you can make calls, send GraphQL queries, and then you load your data. So what does it look like? You have most of the times, if you have an HTTP server, you send it. You can send at least a query document where you define what you want to load. Then you can optionally send variables. We'll take a look at this too. And then there's a third variable that you can send if you have multiple queries. But let's take a look at it. So the easiest query is you put this in parentheses, and then there's like a graphical explorer here. It is also a component that's open source by Facebook. You can use it on your own GraphQL API. So it's not part of GraphQL specifically, but you can use that with GraphQL APIs. So what Graphical does, it sends a query to the server in the background and loads everything that's available in that server. It's like an introspection system where the server can specify what types does it have, what queries does it have, what input arguments it has. And there's like a type safe specification of the API. It loads all those fields. So I haven't actually played with this GraphQL API, but since it's GraphQL, you don't need documentation, you don't need knowledge really. You can just look at the introspection result and you know exactly what that server is capable of. So if we write a query, we just use parentheses, and then you can use control space to see, to get autocomplete features here and load things. Let's say we just want to load the capsules. And then we see here capsules is an object, so we want to specify what fields we want to load. So let's say we want to have the ID, and then we want to have the status. What other fields are here? Let's see the type. Well, let's run this query here. You can just press play. And then you can see you get a response. It's a JSON object, which just returns the capsules, and then the ID and the status. That's like exactly the query that we passed here. So that way you can compose your query result. So like, you can make as complex of a query as you want. Let's say here for the capsules, we want to see all emissions. Say the name. You can prettify it here, and then we run play. So now we get the capsules with the ID, the status, and the emissions. We don't have to do a single change in the backend on the server. We can just say like here, this is the data that we want. Want to have the name and the flight. Let's add the flight 14, 7, etc. So this makes it really awesome to just query data and you just say what you want, and then you get the result. And this is also the query that you're going to use in your front-end application. So in React, Angular, Vue.js, whatever you're using, you just send that query and you automatically get that data. You don't have to worry about like creating backend endpoints, etc. Okay, let's make this a little more fun. So you can load like one result, but you can also combine multiple. Let's say we not only want to have the capsules, but we also want to load some company information. Like usually with REST, you would have to create like a separate API call, etc. But here, if we create a page, we just define this query and add the company information, and ta-da, there we go. We have the company CEO, so we can display that information on the page. We can also, we can see the COO, and then like also drill down here. So like what are the? It has 3 vehicles. Yeah. And you can see what's available.
How are you getting it to come up again?
Say again?
How are you getting it to come up again with those suggestions?
With those suggestions, just control space. Control space. So we can just see here address and what's the city. So you can like really easily build your queries and load this. Question?
If it's a big query, how does that performance, how does it affect small since it's a really, what if you add like a lot of parameters compared to REST?
Yeah, you have the performance question. That's actually like I think the hardest part, which is I mean at the front end you have full control over it. You can just split it up. Like if the request is too big and you'd rather send 2 requests, you can just send one request like this and the other request separate. So like if you want, you can split it up. Sometimes you want to load like what we do, for example, in the backend, is we load like the frame, you know, like with the user, the avatar, and like some account information, etc. And then in the second call, we load then the page content. So it depends how you want that page to, you know, how you want that page to load, right? So here you can just compose the query as you want. Does that answer the question?
Yeah, I have another question. How do you know that you're going to get multiple, you're going to get an array or an object back?
Okay, so this is part of the type system. Here you can open up the documentation here on the right, and then you can see here the query. You see like on the users field, for example, we also see input arguments. We'll take a look at this afterwards. And then here you see this is going to return an array of users, and the exclamation mark means it can't be null. So like here we know on this field we're going to get an array of users which can't be null, and then users aggregate. Here we get a users aggregate. It's not in parentheses, so like this is an object then. And we can click on it and see what this object looks like. You like aggregate, here are some fields, and then this is how you know like what data you're gonna get back. And another thing is like you can use this information to automatically generate like TypeScript types, flow types, types in Golang, etc. So this is really nice. And then you have autocomplete and validation in your front end, like right from the server, without having to do any additional work. It just works with the GraphQL standard since it's a strictly typed language. All right, so now we have a query. We can load data here. Let's say we want to filter those, or like add some pagination logic or things like that. So this is different from server to server. Like the server can decide how it's going to be implemented. So like here, you can add, say like here, limit. Let's say here we have capsules a lot. Let's say we only want to have the first two. Then we can see here also with command space is how we want to like what arguments available. So like on those fields here, this is what they're called. You can pass then input arguments. Let's say we want to limit this to 2. And here we go. We only have the first 2 capsules. And we can say here sort. Want autocomplete here. I don't know why. Or it just expects a string. So sort by status. It'll work. Yeah, there we go. So it depends on the server. Like whatever the server offers, like they can add arguments. So like you want to add sorting functionality, you implement that on the server, add that argument, and then you have to implement the server fetching logic, like how you sort it, etc. Yeah, so this is how you build queries, and you can do this. You can also add arguments here. You can. That one doesn't have arguments. We have here in the landings. So you look what the server has available, and then you add this. You add the queries here. We can take a look at another server that you also built, and afterwards with SlickNode. Okay, so this is like a very basic query. Oftentimes, another feature that you can do is you want to have this flexible here. Let's say you don't want to hard code this into this query. Let's say you want to have like a drop down where you can select the number of results. You want to pass an argument to the query. It can also be an ID if you load the specific capsule. Let's say we want to make this input argument dynamic, that we can like reuse that query that we can put in our client application, and then pass that dynamically. So we just define a query here, and then in front of this here, you can say this is a query. This one is, we can omit this if we're just sending a simple query, but oftentimes you would write query, and then you can give it a name. It's like here, page data, or it's like, so this is, so this query still works. We say like it's a query, we give this a name, and then on this query here, we can define input arguments. So input arguments are defined like this. It's like, let's say we define a limit, and then we say what type it is. Like here we have the limit variable defined here inside of our query, and we say it's of type integer, and then let's say we want to make this required with the exclamation mark. And then we can use that variable here instead of the hard-coded value. So, as I do it, what does it expect here? Limit, integer.
You need to give it a variable name?
I give it.
Or you gave it,
You call
Maybe
it input there.
maybe you should put input there. Maybe you should replace
Limit versus input.
You should replace it with input.
At the top when we declare as limit.
Oh yeah, that's right. Thanks. All right, there we go. And then we can send the query document along with just a simple JSON object of variables. So here we pass limit, and now we have the first two. Let's say we have first three, and we can change the limit. We can run the query again, and here we get now we get 5 capsules or 6. Sorry. So this way you can write the query once, pass it the query variables, and then you get a result back. Let's quickly take a look at what that looks like on the network tab. So like if you run this query here, what it basically does is probably like super hard to read here. Let's see if I can zoom this out here. What it does, it just sends like a payload in the HTTP request. It sends the query, which is the document that we wrote here in the browser. Then it sends the variables, the JSON object, and then it also sends an operation name, which is the name we gave to the query here. Right? So this is what it sends to the server, and then it just returns the response here as a JSON object, as data, as a company information, etc. That's pretty much all it is. You send it, we send it the query, variables optionally, and the operation name optionally, and then it executes the data and returns exactly what we asked for. So that's pretty much all it is from the client side. Another thing you can do, you can also define multiple queries here. Select page 2. Inside of the same document, let's say here we want to load our users. So this is I don't do that as often because usually you want to send like one query, not like make the query document as large. But just so you know it works, now you can send like the full query document and then just pass as the operation name page 2. We can see here. Now we pass the operation name 2, and now it executes this query here that we have in where is it here? The page 2 query, and returns the users. That way you can put like any number of queries inside of that document, and yeah, then load the data. Other questions so far?
So the server remembers state then from previous queries?
Say again?
The server remembers state then from previous queries? Is that what's happening there, that it's actually saving that page data and then you're just able to reference that in future queries?
So it does not reference that. I'm not 100% sure if I understood your question correctly. Because you're always like you're sending the query and then you get the data. So like for the next request, we send another request, and then here we send the operation name of the query again.
I see, it's all makes sense. Okay.
Yeah.
Sorry.
You can persist queries like if the GraphQL server allows that. So like there's methods that you like store all the query documents on the server, like in Redis or whatever, and then you just send the ID of the query. Like this is an option that you can do, but it's not specific to GraphQL. It's like something you can't implement if you don't want to send the whole query document, like to optimize that too. That's the way of doing that. So, all right. So those are queries. Now let's see.
Are we gonna get to how this interacts with like a database language like SQL or etc., like a NoSQL query?
Yeah, I'll show that briefly, like how to implement it in principle, and then I can give you references like how to go deeper in that. So, okay, another nice feature is like the use of fragments. I think this is actually the biggest feature for the query part that makes that dramatically reduces the complexity in front-end applications. This is called fragments. So like let's say you have a front-end component. Let's say you have a little component where you display the mission and the flight. You build your React component. Let's say where we have that. Let's execute this query here. So let's say you want to display that in a certain way, and then you have like the number of flights it has done. Let's say you want to put this into a React component. What you usually do then, you say here fragment mission, and then we define the type on capsule mission. So this is what a fragment looks like. You have a fragment, you can give it a name, and then you define on which type you have that fragment. So you have a flight, you have a name, and what you can do then, you usually define this alongside your React component, because you say like this React component always needs a flight ID and the flight number and the name. And then you can use that fragment inside of the query. You can say here, in this part of the query, I want to load all the data for my specific React component. Right? So here, it still returns our name and the number of flights. So in this way, you can modularize the GraphQL query. So like for every component that you develop, you can create your fragment, and then at the end, compose them into one query and send it off to the server, and it automatically compiles the result and sends that back. And this is a major game changer. It's not possible with REST at all. And the advantage is like this. So this component, if you use that component on like 5 different pages with like 5 different queries, you can reuse that fragment. And whenever I make a change to it, like inside of that component, this capsule doesn't have many fields, but let's say you want to remove the flight here. We don't need that anymore. We just change that in our React component, and then we don't have to touch anything else in the queries here. We send the result, and it only loads then the name. Right? So this way you can create modules of query parts and then compose them to like one big query that you send to the server, and the server automatically figures then out what data you need. So this dramatically reduces the complexity in the front end. And you can also combine multiple fragments. Let's say we have another mission teaser on capsule mission. Let's say we had another scene, then here in this, let's say in this component, we do need the flight number. We can add multiple fragments here and compose them. So like mission teaser, run this query, and now the server automatically merges those 2 component dependencies, like the data dependencies, figures out what data to load, and returns the exact result, which you can then pass to your components. And this is the magic of GraphQL, because you can have hundreds of components, each have their own data dependencies as part of a fragment, and then you put them in a query, combine them, and then the server does all the rest. So like inside of your React components, you just define all the fragments. Then at the top level, at your page where you load the data, you just like combine all the fragments, and then the server does the rest of the magic. Yeah, we can take a look at this. This is by far my favorite feature of React. Other questions?
You're gonna cover like post requests.
Post request?
Yeah. Would you make a post request with something like this?
You mean like making changes?
Yeah, like making changes.
Making data changes. Okay. Yeah. Let's take a look at this. So far, we've only done read requests. So like we've just read the data that's available via the API. But what if you want to make changes? So there's another part of functionality that you can implement. So those are called mutations. So you mutate the data inside of the server, and it works exactly, almost exactly like the query. We can give it a name. But first, let's have a look what is available as mutations. So like here, we can insert users. I'm not sure if that's actually implemented here, but then you can pass it some data here, name, and then return ID. So here it's complaining that we need to name this because we have multiple queries in a document. you can put multiple queries in one document, like the query and the mutation, but you all have to give them different names so you know which operation to call. So like here, create user. Yeah, so here we can either like hard code this into the mutation, and then we run this query here, create user. Here, it has created a user and has returned the ID and my name. So this is how you do changes, and like how it's stored, this is implemented on the server then. So like it takes those input arguments and then you can do whatever you want. You can just like write it to your database, like use your Mongoose models or SQL or whatever you're using. You can just take those values here inside of your code and then perform whatever write operation you want. And another great thing is you can specify what data is returned. So like here we say like we're creating a user, and then here we're returning this data. And let's say we want to get the name and the ID, and then we have that data available automatically in the front end. So like how this is useful. So like we can use that ID then to like redirect to a profile page, for example, to do like another query, like where we show more information or create other objects. Or if you update something, you can return the data and then, for example, invalidate a front-end cache, that it automatically updates like all your React components where this particular data is used. Let's say you have like a user name displayed like in the blog application in the comment section, and then someone changes that username. You can do that like right within one API call. You just like update the username or whatever information like the avatar. Then you immediately load that inside of that mutation and then update that on the client everywhere in your React application automatically. And there's clients out there that do that automatically for you. So this makes it a lot easier inside of the front end here. Yeah, so this is how you do changes. It's pretty much the same. The only thing that's different is mutation. There's one other small difference, but this is like an implementation detail of the server. So like if you do multiple mutations, you can also do that. So like here, we can update users in the same request. So like here, set name test where I don't know what's implemented here. Let's see. I've never worked with this API, but just with the autocomplete, you know immediately what's going on here. It's like, let's say we update this name here. Set name test, returning ID name, create user. So here we've created another user eval, and then here we have updated the user returning test. So that's how you do mutations with GraphQL. And you can implement whatever the server supports. And if you write in your own server, you can decide like what mutations or write operations you implement. And this is usually like if you create a GraphQL server, this is the majority of the work that you need to implement, all the logic that you want to expose. Does that answer the question?
I have a question.
Yeah.
So we go back to the fragment that you said earlier. Is that the fragment will be query on the front end or is on the back end? And is that with the fragment is require the front end developer to be more knowledge about what they do in order to get the optimization that fragment provides?
So you're asking like if it's required for the front end developer to write this query, or
No, like is a fragment is be implemented in the front end?
so for the you're asking if it's easy for the front end to
No, I mean
use-
like is the fragment that you saw earlier that you call the piece of information fragment, and then later on you combine all that fragment to be optimized to have this optimized result without having to be queried like deeply nested level many times because of the fragment is being loaded upfront. Is that being queried in the front end at the first load, and how is this optimized? Like I ask him like, is it even on the back end or on the front end?
Oh, you mean like the fragments, how they're merged and like how this data fetching logic happens?
Right,
Yeah.
and that is that fragment there that when you write that fragment function there, I don't know, is that function or is that a query? Is that on the front end? If let's say if you have a React app, where do you will put that fragment?
Yeah. So those fragments, they usually sit like right in that component where you need it. So you have like your data dependencies right where you write the React code. And then like if you want to add something, you just add like a field to the fragment. Let's say you want to display the number of flights, like you get that requirement from project management, then you just add that field and then you display it. And then all the query logic, like the optimization and the merging and stuff, this is done in the background by the GraphQL server. You don't have to worry about any of this as the front-end developer. All you do is you write the query, you write your fragments, you compose your fragments, then you send the query and you get exactly that data back. So it makes it incredibly easy. You don't have to worry about like when you load the data, how you load the data, what are the data endpoints, like what is available, etc. You just write the query and the queries with the fragments, you send it to the server and you get the data back.
So if you have certain fields that are protected for certain user classes, is that filtering on permission typically done? Do you have a layer that sits between the GraphQL and the front end that's actually doing the permission checking?
Yeah, this is a really good question because there's like a really difficult topic in GraphQL to implement that right. And SlickNode, which we're gonna start looking at, that has all that automated under the hood so that you don't have to worry about this. Because this is like one of the hard topics. If you develop a GraphQL server, you have to worry about this. Like you have all those queries implemented, and then inside of your GraphQL server, like how you structure that is a different topic. But like inside of your GraphQL server, you have to manage that business logic. It's like, is this user allowed to see this capsule? Is he allowed to like create users? I'm surprised I'm allowed to like here on the public API create users, but. Yeah, so like usually you would put like an authorization method in there. So like you can send then like JSON Web Token with the HTTP request, and then on the server side figure out like, oh, who's this? Who's calling there? Is it allowed to do that? And then either return the data or like throw an exception or return no results, etc. But this is something that has to happen on the backend side, and this is a lot of work most of the time.
So what if it fails? What does it do? Like, what does it return?
So that's like different failure scenarios. So let's say we write like a wrong query here. I'm gonna just see here, create page. Then you get, instead of data object, here, you see like here, create user, you get the data object, and if you get, instead of data, you get an error. Or you get a list of errors, and then it tells you also, like, if it can, it tells you the location. So like here, line 6, column 7. So here, this is where I messed up. And then it tells me here an error message. And then here, there might be extensions from the GraphQL server where you can like expose additional information. And you can have like a list of errors, etc. Then
Is that in documentation? Also, errors?
errors is also part of the GraphQL specification.
I'm saying the code, is it going to show up if I look at the docs or no? The GraphQL validation code.
Yeah.
If this is in the docs.
Yeah, like the type of messages you're going to get, the type of.
No, so this is not part of the GraphQL specification. So every server can implement it however they want, and those messages can change. So if
I'm saying like for a certain API, is it going to show up as it in the doc? When that docs.
if it's good documentation, and so it's not a requirement, but if they might show it, or like might also be like a generic error message that's like generated from deep in the system if you want to expose it. So like it's up to the GraphQL server, like if they document it, how it's going to be exposed. The only thing you know for sure, it's going to have a message here. This is part of the GraphQL standard. It might have a location if it knows where inside of the query that happened. And optionally, it can have extensions. So like you might have an error code that's like part of the GraphQL server that's implementing that, and they might document and say like here, oh, those are the error codes that can be returned.
What about like those numbers like 502, 400? Like, is it gonna return that stuff or like?
Yeah, this you can't really return this because there might be parts of the query that work and other parts that fail. Let's say you have like here, you run a mutation, you run 2 mutations. The first mutation might succeed, and then the second mutation might fail. And then there's not like really unique error code that you can return. You can it usually returns then error code 200, like if you're talking about the network response.
Okay. So it's
And then the error is handled then via the error message. There's also then a network failure. It's like you can't connect to the server, things like that, or you get an actual error code. This is a different error scenario that's like outside of GraphQL, since it's like usually implemented in the GraphQL clients, but it's part of the it's not part of the GraphQL standard. The error codes.
So is it gonna always return 200 or?
Most of the times, yeah. Here, let's say sometimes those servers do a little differently. Let's say here. Well, let's not add too much data here for them.
Oh, okay.
Yeah, here, this one returns 400 bad request. So it's not really specified in the specification, but yeah, it can return 200. Most of the time returns 200.
Okay.
All right, okay. Yeah, so those are most of the features you need to know for GraphQL, and you can just write the queries and then get the data and load the data. Any questions so far?
Not yet.
Not yet. All right, so then let's take a look at how we actually build such a server. So like from the front-end perspective, if you get a GraphQL API endpoint, you know exactly what to do if you know how to use the GraphQL query. I've never worked with the SpaceX API, but you can use it anyways because it's just self-documenting. Like I don't need to read documentation, I just use it, which is awesome. To define a server, this is usually done via the schema definition language. It's also part of the GraphQL specification. This is where you can define what is available inside of the server. You can define the types, you can define the input arguments, you can define the mutations, etc. It's a type-safe API definition, so you can't just like return any data you want. This is like the whole point of GraphQL. So in this schema, you define your entire application, everything. You define the mutations, you define the input arguments, you define the return values, you define if it's optional, if it's not optional. And so this schema is then used for the introspection, for what we've seen in the graphical, to like generate all the autocomplete, etc. And you can also, there's plugins, we can have that like directly in your IDE, the autocomplete like right next to your React components, whatever. Or you can use the introspection result for code generation, for TypeScript types, etc. So what does it look like? You define types. It looks very similar to a lot of systems where you define it. It's just like you have types. They're called type. Those are object types. Those are the basic building blocks, and then you can compose. So like here, what data structure you have. Here we have ID, and GraphQL comes with a bunch of predefined types. For example, an ID is defined in the standard. There's a string. There's this is something else. There's an integer, and there's then you can define your own types and nest them. Let's say here we have we can define a comment, we can define a post, and then somewhere else we've defined the type user, which we can then reference here. So you can define your hierarchy of responses, whatever it returns. And then here, if you look at the image, you can see we can also define the input arguments. And here too, you define what type are they. Is it an integer? Does it return an image? You can have multiple. They all have a name. Kind of like you define a function. Nothing special about this really. So let's look at object types a little in detail here. So here, for example, we have an ID. We say like this is required, so this ID can't be null. So like whenever we return it, we ensure that it always returns value. Then here, first name, string, and then here you can also add comments, descriptions, which are also available then in the Graphical Explorer or your IDE. So you can document your types right in the system, and it's automatically upgraded in the API. So like you'll never have again like an outdated documentation. You can add this to all the fields. You can add this to input arguments, etc. Here's an optional username without the exclamation mark. So let's say like this field is not required. Then we have a Boolean value. It's also, this is optional now. Here it's an integer, which is required. Here we have another required user, another required float field. Float is another data type. And then user, this is like, we can reference the same type too, so like build recursion of types. So like here, this is required, always says the mother and the father. And then here we can say like return an array of objects, like a list of objects, like here in parentheses, we have the user, it can't be null, always returns a list. That list might be empty, but it can't be null, that's why we use the exclamation mark.
Kind of reminds me of like the value of like a Swagger, where you have, you can require certain pieces. I'm not sure if there's actually like a way to ensure when you have Swagger, when you create a request and all the pieces that go into the request, what's required and what's not. I'm not sure if there's a way to ensure that. In this case, if you were to provide like a request on a user without the ID, for example, is it saying you have, when you do include the ID in your request, it will always come back as non-null? Or is it saying you have to include the ID in your request for it to be a valid request?
No, it's the first one.
Okay.
So like you can define your query how you want it, but you say like if I want that ID, I'm always going to get a value.
Yeah.
And if the server, like for whatever reason, does not return a value, returns null, it's going to throw an exception instead, an error. Obviously. So you can always like load whatever you want, but if it is required, you can be sure in the front end there's always going to be a value there. Make sense?
Yeah.
All right. Okay. So those are the basic building blocks how you build your schema. There's another type. It's like enum types. It's like just a set of values which doesn't change. For example, for a status or for like something like that. You can give it then fixed values. You can also document them with comments, as we've seen before. Then for complex input types, there's the types, as we've seen, like the type object, and there's another entity which is input types. So like if you want to use complex objects as your input types, you have to define them as input. It's just like a small change. So you can't use types as an input type here. It's not possible. You have to define them as input. Right? It's just like if you want to use complex objects as input arguments, you just define them as input instead of type. That's it. And then you can return like whatever you want to return here.
So do you need to, like let's say you have invoice item is both an input for a mutation and a type that you can get later. Do you need to define it separately? Like
Yes.
Okay.
You have to define them both. You have to define them both. And then you would like name them like invoice item input, and then you can't have the same type with the same name. Like they have to be called differently. But as you can see, like if you're developing your API, you're gonna usually define like a lot of types, like with everything, input arguments, complex data structures, etc. Another feature is interfaces. So you can also define an interface, and then have other types implement that interface. That means you can define an interface here, let's say SEO page, and then define title, keywords, description. And then if you implement that interface on a type, it always has to have those fields. So like if I were to remove this field, it's going to throw an error. The advantage of this is you can write query fragments for interfaces. Let's say you have an SEO page interface. Then you can write a query fragment for like the header component, and you can use that on every type that implements the SEO page. So that's what interfaces are for. You can use multiple interfaces on the same type. There's also union types. Let's say you have a dog and a fish and you want to define an animal. You can define a union type like this and then define the fields like on those types here. That's another thing. Okay, we've covered this. Are there any questions so far? Okay, good. Then let's have a look at how we actually create a GraphQL server. Right, so we know how to use it, what it's useful for, and how to implement that. And so I want to show you. So when Facebook open sourced this, I thought like this technology is awesome. It has like a lot of features which you can use to automate a lot of the things, like defining the types, defining the fetching logic, all those things. And this is when I started working on Slick Node and to automate a lot of those things. Because at the end of the day, what you mostly care about is an API that gives you the data that you want at the right time. And you don't really care about like how it's fetched or not. And you also need to be able to like do that in a timely manner. So how you can do that, for example, in Node.js. It doesn't have to be Node.js. It can be any programming language that offers GraphQL server. You can go on graphql.org to find the language and libraries that are available. So what that looks like, here you just like load the, install the dependency. For example, with Apollo server, it's like the most popular one for Node.js. Then here you define the types as we've seen. As like the starting point, you usually define a type called query. And then here you implement all your types. So like here, we just have one server which loads hello world. So we define one field here. And this is our schema here. Very simple. It can be really large. Usually it's like hundreds or thousands of lines with all your type division, documentation, etc. Then as another part, for the actual fetching logic, you implement then resolvers. That's what they're called. You implement a resolver where you return then the data that should be returned by the API. So here we have for the query type, for the field hello, this field here, we just return world as a string. So like if you were to start that and send a query there, you get that data back. And this is also the part here where you can then talk to a database, like load data from MongoDB, load data from MySQL, from PostgreSQL, or whatever you're using. So like here, you can implement the fetching logic. You can do the authorization. Say like here, the current user is allowed to view that data. If not, then return null or throw an error or etc. So this is where the majority of the work happens. And this is also where you have to implement then an efficient way to load the data, which is like the most difficult part of implementing a GraphQL server. To get like, I mean, it's nice if you can load everything, but if you crash the server on the back end, it's also no use. So like, this is where like most of the work happens then, instead of those resolvers and for the fetching logic. Other questions?
So if you had a SQL database, you would just basically map all the tables and rows, or all the tables and columns to resolvers and return that back, and then put whatever authentication logic you wanted on top of that.
Exactly, exactly. So you create here, if you have like complex type, let's say you load the user, like here in your resolver, you write then like model find by ID, etc., and then use the input arguments and return it.
Okay, and this is just executed once on server startup. This isn't for every request. This is
The resolvers run on every request because it can change like
no, but
depending on
like the parsing of the type definition, all the line.
yeah. So this is done like on the start of the server. Actually, here we haven't started it. I omitted that. But here it's like server.listen on port whatever. So like you start that, and then like for every request, only those resolvers are executed. Or however you implement it. Like you'd also implement like a different way of like how it resolves things. So like that's not specific to GraphQL, but usually it's how it is. You have the resolvers which return the logic, which return the data where you have all the logic in that. Does that make sense?
Can I ask one more question?
Yeah, sure.
So if you had so your resolvers, let's say you had 2 different columns, and so do you run a different SQL query to get each of those columns, or you typically run one on the whole? I'm curious how this, if you're writing this and you had your data sitting in a MySQL database, I'm curious that translation, how you would do from implement SQL queries to return resolvers for Node or for GraphQL.
Yeah, you can do it however you want, pretty much. What you can do, like inside of this resolver function, it has like a few input arguments. They're not listed here, but you have, for example, the parent type. Let's say you have a type invoice, and then you have like all those invoice items like nested as an object, right? Then you can write one resolver to get the invoice, and then you can write one resolver to load the invoice items. Or what you can also do, like load the entire object before. Or what you can also do, you have available the information in the resolver which fields are requested by the client, and then you can decide, oh, I'm only going to load like those 3 fields from the database that are requested, and not the others. So like it's up to the implementation of the GraphQL server how you want to implement the server logic. Does that make sense?
Yes. Thank you.
Okay, so this is really where like the most of the work goes into when you develop a GraphQL server, like the data fetching logic, authorization, business logic, making it efficient to load. Yeah, so usually what you would have to do is like define the schema, implement resolvers with data fetching logic, which is a lot of work if you don't have like a data fetching layer in your stack already. Yeah, set up data storage, models, DB connection, etc. Network configuration, authentication, like who's talking to the API, this kind of stuff. Authorization, who's allowed to load which data. Security, it's a big topic with GraphQL. Like, what if someone writes a query to like get users of like friends of friends of friends of friends, you know, that can like load the entire database and trash a server? You need protections for that. I actually wrote a library for that for Node.js server. It's like the most popular with 1.8 million downloads. It's open source. So like if you implement a GraphQL server on your own, like I would use that. It's GraphQL query complexity. You find it on the Slicknode GitHub page. Yeah, then you set up the usual stuff like deployment, CI pipeline, infrastructure setup, monitoring, logging, load balancing, this kind of stuff, CDN, serving it from the edge, etc. So when GraphQL came out, I said like I wanted to have a stack where all this stuff is automated. Like use GraphQL as a foundation, and then build a platform on top where I don't have to worry about this. And this is how Slicknode came to be. I started playing with that like about 3 years ago, and right now I have the platform ready to be used, and I'm actually running the platform like on Slicknode. And like what that looks like, you still have type definitions. There's a few conventions to use. You just define your schema, and everything that's persisted to the database implements the node interface. You can define that in your code, in the local code. Then you run a deploy command with the command line tool, and that's it. Then you have a GraphQL server. You don't have to implement like any data fetching logic. You don't have to implement any authorization, authentication, any of the infrastructure setup. That's pretty much all it takes. And this makes it incredibly fast to develop really complex applications. So what does Slicknode do automatically? It oh wait, yeah, let's actually let's do that live here. So it's gonna be brave. I hope it works. Okay, so first, like to get started with Slicknode, like anyone can just like install it. You just install the Slicknode CLI globally on your machine. Let's make it a little faster here. I already have that running, so like I'm starting from scratch now. So there's like nothing I've prepared here. Slick node, just initialize the project, slick node init, blog demo. Let's create a simple blog application. We can show what slick node is capable of. So here, select the cluster. There's like one legacy cluster. Don't put anything on there. Just use the AWS thing. I think it's also a little. I'll show you. So now it's deploying, creating a new GraphQL API. It's provisioning the infrastructure. It's setting up the API endpoint. And here we go. Here's my GraphQL API. Sometimes it takes like a few seconds to load up. Let's give it some time here. This is only initially when we created. So here we have our GraphQL API. That's it. So we have our GraphQL server, and it comes with like a few predefined types. For example, if we want to load the current user, select your first name, last name. We predefine this, and right now I'm making an anonymous request, so the current user is null. So this is all it takes to create a GraphQL API. But just having the current user, there's nothing really on there. Let's create some blog functionality. And when I developed SlickNode, I wanted to have a system that's completely modular. So you can have any number of modules and compose them. Because otherwise, if you have a monolithic application, like it can really like get out of hand. And I wanted to have an application where you can have modules that you can completely like share with other applications. Let's say you develop a blog functionality with all your front-end logic, and you want to reuse that in a different project. It's just copy-paste. That's it. So you develop functionality once, use it everywhere. So SlickNode module create blog. Then I need to do a directory here. Blog demo. SlickNode init. SlickNode module create blog. Let's create a blog. Then you give it a namespace to like avoid type collisions. Let's say we call it blog. And then we say like what we want it to be called in the admin interface. And here we go. So like add your type definitions to that file. Let's open this up in IDE. And here we see we have SlickNode created something. It has a file here in the root directory with all the dependencies. There's like 3 modules that were installed automatically. There's an authentication module, which has a user and like the viewer, for example. Then it has a core module, which has like a bunch of core functionality, and then relay. So like SlickNode is completely compatible with the relay standard. There's also something that's not that easy to implement because there's usually not like a direct mapping of like relay compliant GraphQL responses to databases. So you have to put quite a bit of work into that. SlickNode does that out of the box with the relay module. So let's see, we have here.
Can I get the last 2 commands? The one that you used to run the demo and then...
To initialize that?
Yeah, it was the one you did after you installed.
So I ran SlickNode init and then gave it the name. Like you can use whatever name you want.
Oh, okay, gotcha.
And then I changed into the project directory and ran SlickNode module create blog.
Okay, good, thanks.
So these are the same commands on slicknode.com/docs/quickstart?
Exactly.
Okay.
Yeah, I might use different types. I don't
Okay.
exactly know like what's in there, but yeah, there's like everything we do here. It's like there's like quite extensive documentation how to do that. So you can follow along and like look it up there, and also on the website slicknode.com there's a Slack channel where I'm always online. So like please join there, and then if you have a question, just like ask in the channel, and I'll help you out. Okay, so here let's take a look at the code. So it created that SlickNode YAML file in the root directory where it just like has those core modules, and then it also links to the folder here, modules blog, and inside of that folder we have. Let me make this a little bigger here. Is it better? Yeah. So here inside of that blog folder we have a schema GraphQL file. This is the schema file inside of that module. So here we can define all the types for our blog module. Let's just do that. And we use the schema definition language to say blog post implements node. usually always want to implement the node interface because this tells SlickNode that we want to persist this in the database. It creates the database tables and it has to have an ID. So this is usually how you start a type, and then let's type it away here. So like here, we have title, and we have the text. Then there's another nice feature that SlickNode has. You can add, you can configure the input type via directive. This is another feature of GraphQL. You can add directives of like part of your documents where you add like special instructions for the GraphQL server. And then here for the text field, let's say we want to have this to be marked down. And there's another built-in interface in SlickNode. It's the timestamp interface. This automatically adds created at and datetime fields last updated at. So if you add those two fields here, they're automatically then updated under the hood. We don't have to implement this. If we add this interface, those two fields, another functionality, we can, but we don't have to add that. It's just like creating this. Let's add something more. Let's say we also have a category. Also implement the node, and then we start with the ID again. And it has a name, type string. Let's say we also have a slug of type string, and we say this is supposed to be unique. Let's add that for blog 2. You can say here this has a unique value, and yeah, let's see what that looks like. So like once you're done with your schema, you can say SlickNode deploy. And so it compares the local changes with the state in the cluster, and then it tells me like what happened here, and then if I did anything wrong in that document, so like there's a naming convention wrong, or like a field type is missing, or interface is implemented wrong, it's going to tell me, and then I can just go back and fix it. And say like here, okay, this looks good, just deploy it. So like deploying changes. There we go. So now it has updated the GraphQL server, and also let's open up a console. So what SlickNode automatically does, you have your data model, and based on your data model, it automatically creates a CMS for you. So here we have our blog module. And now we have automatically CMS, a backend, back office interface without writing a single line of code for that. So here, let's create our category. So like here, sports, add our slug, add this, let's add another one here, tech. So if you keep away, then you have automatically your admin interface where you can have visibility into your data. And then here, let's create a post. Here we have our markdown editor. Like title, but here we have like a few fields missing. We have like title, slug, text. Let's say we also want to give it a category. So the great thing is like with SlickNode, you can just add that type in your schema. Add this here, blog category. Save the files, and then run another deployment. So you can commit those files to GitHub, you can merge them, you can do code reviews, you can revert them, etc. So because everything happens on your local machine, it's also a big differentiator to other systems. Like a lot of other systems, they have like this platform where you do like dozens of clicks and then you can do things, but you can't implement that easily to your usual workflow. So like you want to develop something in a feature branch and then merge it. Like create a separate module, then move that module to a different project, this kind of stuff. Like with this local workflow, you have all your files locally, like all this is a no-brainer. You just like write your type schema, deploy, and then let's look back at the schema. So now we have a category drop down here, which automatically loads our types here. first post. Whatever. And then we have like markdown editor here. Title, this is some markdown, etc. Save that. And then it automatically added the created aid, last updated add date for us. Okay, so this is the CMS part of it. Then we can also, let's say we use a playground here. A little small here, but it automatically generated like all those fields with the fetching logic. We don't have to write a single line of code for that. Let's say we want to get our posts. We want to have the text, the title, and the slug. Let's return this, and here we get our data that we just stored in the CMS. That's all it takes. Then let's load the category for that too. ID, name, prefix that, etc. There you go. This is your GraphQL API, all the data fetching logic, which you can then use in your front-end application. Any questions so far? All right, let's keep going. Okay, so let's extend this data model a little bit more. So there's some more built-in functionality. For example, handling images seems really trivial, and for a lot of applications you need images. But to implement that right at scale is pretty difficult because you want to have like different resolutions. You want this to be you need to store the data. You need to like generate the thumbnails. You need to have it scalable. You need to like expose it via CDN. So this is usually like a lot of work that goes into handling images. Slicknode has a module for this. So there's like a bunch of modules that are already part of Slicknode. Let's say, and you can just install it. So like Slicknode module add image. You just install this module. It's like your module image was added in the version latest. When we deploy it, and it says like here, it adds those types to our system here. We're deploying those changes. And now we have an image type available, which we can just add here to our type. Let's say each blog post should have an image. And do that. Slicknode deploy. So you just add the types, redeploy, and so now we have changed to type blog post. Deploys the changes, and now we can reload our. So let's reload our data here. Let's see our post. We edit this, and now we have an image upload here. Let's drop an image here, and there we go. It automatically generated the thumbnail for us. Let's save this and see how we can use it in our GraphQL API. So here we have our playground. Let's write a query. Get our posts, get our title, the text, and then we also want to have the image with the URL. And here we go. We get an image URL, which is automatically delivered via CDN. And then we can use the GraphQL features with the input arguments. There's also a feature Slicknode provides. For example, here, let's say we want to have a different height. Let's say we want to have 500 by 500 pixels, and then resize method smart. So like it zooms on the face of an image, so it doesn't crop like in the middle of the face, for example. We run this query, and here we get a URL. So like we can use that then inside of our application, and here we have exactly the size that we want without writing a single line of code, and the image is delivered via CDN, etc. So all it takes to have that functionality, you just need to add that field, say like I need an image here, deploy, and you're done. So this is part of the thing that like Slicknode automates. And then you can have like any number of modules. Let's say you create a blog, you can create like an account management tool, etc. There's like another. you also have like file modules, like if you want to securely store files, we also have access management to that, like that's not public. You just add SlickNode module, add file, you just add this file, the file module to it, SlickNode deploy, and you're good to go. File management, stored in S3 bucket and delivered via CDN. That's all it takes. So, okay, so right now there's some things we haven't talked about, which is also a pretty difficult topic. Is like how to make this secure. Right? Like only people that are logged in can create blog posts. Everyone can read them. Like how do we manage the access to that? There's different approaches how you can do that if you implement it by yourself. Most of the time you somewhere have to implement that in your data fetching logic. That can be in the resolver, where you say like, where you check like, oh, is this like a certain role? Is it allowed to like return this type or not? Or you can also implement it inside of your data fetching logic. Say like here, if it's a user of type anonymous, then apply this filter to the SQL query. So like here, only published posts should be returned then inside of this resolver. So let's see how that works in SlickNode. With SlickNode, we don't have resolvers, and also implementing this in a resolver can be problematic because, for example, if you have a user object that should be returned like for and you have that user object returned on a lot of different types. Let's say you have that on the blog post, but you also have that on the comment. You have two different resolvers inside of your systems, and at every resolver you have to implement that logic to make it secure that that the user is not returned. And the more fields you have, like the less scalable that is. How to limit the access, etc. So SlickNode does it a little differently. It has a built-in, it has a query engine, like how it loads the data, and the authorization part is directly baked into that query engine. Like if you send a query, SlickNode builds the SQL query for you to fetch the data, and at that point it applies the query, the filter logic, depending on like what role accesses the server. So what does that look like? Let's say we have a post GraphQL. So like for every module, for every type, SlickNode has a permission document. So here it automatically generates some default permissions. We have the blog post, and we can define, here we have 3 permissions. We can define any number of permissions, and they work as a whitelist. So here, for example, the anonymous role, which is like anyone that accesses the API without any authorization token, they can only read. They can't create or update or delete blog posts. Then we have a different, another role, for example, staff. We can say staff users can create, update, and delete. And those users also have the anonymous role, so we don't need to add the read permission here. And then runtime, this is like for custom extensions where you run custom code. It's also possible to like write your own resolvers if you have to. If you want to like load external data from an external database, you can just write your own resolver, which is just a simple JavaScript function where you load them from any database that you want. Yeah, so you define the permissions here, and let's say we want staff users to only be allowed to create. They can't create objects, but if I look here, for example, if I go back to the console, I can create. Wait a second. Let's first implement. Let's say we have a blog post, and we want to have an author field here, so that we specify like who wrote that, but we only want to be able to like write in our own name. So let's add this. Let's add the author here. So we add the author field, and we deploy that. SlickNode deploy. So we want to be able that the user can only like edit their own posts, but not posts of other people, for example. Let's say that's the logic that we want. And apply those changes here. And here we go. So this logic doesn't cut it because we say like this is a staff user. We know it's a staff user. We know it can create, update, delete, and create objects. But we need to be able to filter that. So like it's only allowed to update their own posts. And this is where it gets complicated. Luckily for SlickNode, there's you can add a different field to this where you can use the same filtering logic that you use for the fetching to create permission rules. Let's see what that looks like in practice. There's you can either like write them in the document, but we want to use autocomplete for this to see what's available. And inside of the settings, here's a permission editor. If you go in your project to settings, permissions, you have like all your types available here. And let's say for the blog post, we want to create a permission document. That works. That is implemented with the GraphQL query. So like for every rule, you can create a GraphQL query. And here in this editor, we have access to a variable which is the user ID. And we can use that then in any part of the query. So like it just works as any other query. And then here as one field implemented, which is the node field. And on the node field, we can specify a filter. Let's say here for our blog post, we want to filter this. We have our author, and then you say the author, the ID is supposed to equal the current user ID. Right? So what this does, those are two fields that both return a Boolean value. And if both of those fields internally return a Boolean value, the access is granted. So this way, we say like here, authenticated users are allowed to create, update, and delete objects of type blog post, but only if the author, the ID is equal to the user ID. And this filter here, you can extend it any way you want. You can build like rules, for example, if like, I don't know, if the author it's like logins, has logged in, like we'll build some crazy rules here. It's like where the login was like, it's like only users are allowed to create blog posts if they logged in the past, like after 2013 or something like that. So you can build like really complex rules with just 2 lines of code. Let's remove this ridiculous rule here. But you get the point. You can create like really complex filters, and they're automatically applied in the query engine. So let's copy this. Let's say authenticated users are allowed to create, update. We can also say, oh, they're not allowed to delete. Only create and update. And we save this rule, redeploy it. And there you go. That's it. Now your API is secure. So, question?
Where was the my permission one used? Where was it implemented on any of the blog posts or the items that we're trying to secure? How does it know to look at those permissions or a specific permission to secure it?
Okay, this is a good question. This is something that happens internally at SlickNode. So what SlickNode does, it takes those permission documents, and actually like parses this and like transforms that into a form internally that's more efficient than a GraphQL document. And it then uses that when it composes the SQL query internally. So this is nothing you implemented. It just takes the type information that we implemented in our schema. So it uses this type information to build all the filters and the filter query. So like based on this type information, we have this filter available here. And like I just use this in the permission editor here to like populate the permission schema. And every type has its own like dedicated permission schema internally. But this is something that happens like internally in SlickNode. Like you didn't define that, it happens automatically. Like SlickNode takes your type information, then generates the schema, and then based on the schema you can define this permission query. And then there's like a lot going on internally, but like, then it takes this permission document, then like checks what's the current role of the user, and then like composes the SQL query. So it's like, does it answer the question?
Yeah.
Yeah. Okay, so you don't have to, or you can't even change it. Like you can only change your like the type system of your types inside of your project, and then it automatically changes the queries.
Yeah.
So like if I were to remove this field here, it would also automatically like yell at me that the authorization rule is invalid. So it does like runs validation, checks like if those validation rules are valid, etc. But this way, this allows you, like those permission queries allow you to build really complex authorization scenarios, which usually take a lot of work to implement. So I just did like with SlickNode a multi-tenant SaaS application, you know, like where certain users have access to an account, and this account has like only access to their own objects, etc. Like with those permission rules, this is like the job of a few minutes. Like you just implement those filters, then you deploy, and then your API automatically does that.
How do you know if you've written something that, some rules or query or something that is running really inefficient on the back end, so doing tons of SQL queries and joins and things like that in order to, is there any visibility into that?
At the moment, there's not visibility into it. If you have like a really complex query, it's gonna time out and then it's gonna fail. So this is, I mean, it builds like the queries in like an efficient way possible. There can be scenarios where they might be tricky. We have like on the horizon is like a SQL editor where you can do that. Or what you can also do is like you define those relations differently, like through different tables where you like normalize data. Like you can do something like that. Or another thing to optimize things, you can. This one already gets an index, but if you have, here the foreign keys also get an index, but you can add indexes on columns to like make it more efficient, data loading, etc. But oftentimes, like those tables where you have like the account management logic, you might have like a couple of thousand users in there. It's like it easily fits in memory. So like for the permission logic, oftentimes you don't need like that complex of queries. Yeah.
But SlickNode is setting up the SQL database, and on the back end, it's transparent to the, or it's, I guess opaque to the developer that's using SlickNode.
Yeah, so right now it's like that's a hosted solution at the moment.
Okay.
What you can also do, like for if you want to do like heavy use of this, you can get like your own dedicated SlickNode cluster and potentially like deploy that in your own AWS account. And for enterprise users, let's say you want to have your own cluster where you run like SlickNode projects, or you want to build like a large scale SaaS deployment where you have like hundreds of clients that each run their own independent version of a project, for example. Like to scale that independently, it usually involves like a lot of engineering work. With a SlickNode cluster, you can just like replicate the project, for example. And it's actually really cost efficient because everything is, like we just did a major relaunch, and I just launched it like 2 hours ago. It's entirely serverless, so like the front end only costs then like when you run a query. So like if you have like hundreds of instances, you can run that on the same database and save cost that way. Or you can run it, like there's like different ways how you can chart it. You can run like multiple tenants on one database or on different servers too. It's also possible. So you can, but there's like a way like how to manage that on the back end side. But right now, like the focus is on ease of use. Like if you want to build a marketing site, you can You can just pull together like the schema, deploy it, and you're done. Or like if you want to productize an API, you can say like you build an API with some technology, but you don't want to do like all the account management and this kind of stuff. You can just use SlickNode to build the account management stuff and then embed that. Does that answer the question?
Thank you.
Okay. This brings me to another point. Another really interesting, another really important thing is that like if you have those platforms where everything works out of the box, it's all nice and fun until you reach a point where you need a feature that's not there. And that point will come if you have like a decent sized project. So I wanted to build a platform where if you run into that point, you still have an answer. You can extend that system. And there are several ways how you can extend SlickNode. So one easy way is sorry about that. Here's like ways to do relationships. That's what I want to show you. So there are several ways how you can extend this. So right now you have the GraphQL API, which we've seen. Then the GraphQL API sits in front of the load balancer. And then from the API containers, those are now actually Lambda functions, so this scales independently. And then this is backed by Postgres Aurora database, so that also scales automatically. And then what you can do, inside of the GraphQL server, there are hooks provided where you can run your own Node.js server. That can also be in your own data center where you implement custom business logic. That could be like a custom mutation, where you like write data. It could be like a connection to an external system, but this can also be event hooks. Let's say you want to do some advanced authentication logic, or let's say you're creating a blog post and then you want to stream that into a Kafka stream or like an Elasticsearch index or whatever system you're using. You can write custom code and then just hook that into the GraphQL server at different points. You can also like talk to third-party APIs. Let's say if you create a user object, you want to write that email address to the to your MailChimp mailing list, etc. It's just a simple JavaScript function that sits then behind the mutation. Let's have a look what it looks like. Another way you can do is you can just add custom fields with custom resolvers. So let's say if you want to talk to a custom database or an existing system or a third-party API, whatever it may be, all you need to do is you define the query, then you enable the runtime here, you define which resolver is executing, in which file that resolver sits, and then you implement a simple JavaScript function where you can call external APIs and then return the data. So that way you can, anywhere in your graph, add custom logic to external systems. So if there's a feature not available in SlickNode, no problem, you can just add a custom resolver. It works for mutations if you want like a certain sign-up flow, or if you want to implement like two-factor authentication or use an external identity provider, all this kind of stuff that can all be implemented with custom code. Another neat feature is so-called listeners. So like if you run a mutation, any of the mutations that are available in the system, you can add before and after mutation hooks. So before hooks you can use, for example, to do authentication, some specific validation, where you say like, where you have like some scenarios where you want to like validate data against an external system, etc. All you have to do is add a hook, write a simple JavaScript function, and then configure that. Or the after mutation listeners, if you want to stream that data into an Elasticsearch index or populator, another system, or like send out email notification, whatever it may be. Listener looks like this. You just configure the listener, say like which event. There's like it's like mutation, create user. So like before we create the user, you want to execute this listener, and then the listener could look something like this. So like here, it has the email address has to end with SlickNode, so only slicknode.com users can sign up. If not, we throw an error. So that way we can't create any users that have a different email address. Yeah, so this is another feature. That way you can add pretty much any business logic that you need, like either through custom resolver, custom mutation, or use the existing mutations and then hook in there either before or afterwards to implement your business logic or connect other systems. Authentication is another part. Let's look at another feature. We have 15 more minutes. Okay, so what if you want to use like, say you already have like a GraphQL API and you want to use SlickNode to quickly, for example, create a marketing page or to add content to an API. Let's say you want to use the CMS to add help text to your internal data objects that you have, right? And so you want to have some help content for users. So you have that data sitting in an external GraphQL API, and you want to combine the two. There's one feature that SlickNode makes this really easy, which is called remote modules. So we have our modules here. Those are all internal modules. We have the blog. You can also add an entire external GraphQL API and merge that with SlickNode, all the SlickNode functionality. So what that looks like is when you, let me show you. Let's open one up that I have here. So let's say we looked at the SpaceX API. What you can do instead of defining all those nodes, etc., what we can also do is here we have two modules. We have our blog module, and here we have a SpaceX module that I created before. And all you have to do is, here you have your module, which is automatically created. All you have to do is specify the endpoint. Here we're pointing to the external SpaceX GraphQL API. And then here we add all the types. You can download the schema from the SpaceX GraphQL API and just add it to the module. So here we have like all the SpaceX API. This is if we deploy this. Let's see, SlickNode Playground. Let's open up the playground. Okay, here we go. So here we have our blog. We can load all the load all the blog articles, which are none in the database right now. But then we also have access to let's load a list of missions here. We also have access to the SpaceX API. So we have in one GraphQL request, we have all the SlickNode functionality, and then we can add external GraphQL APIs without writing any code pretty much. One other cool, you can even take that a step further. If we have the SpaceX API, we have like all the functionality here. Let's say here, for the manufacturers, we want to add some content, right? What you can do then, you can use the resolver and just write a resolver here inside of this manufacturer, inside of this manufacturer object. So you can create an additional field where you say like description that you want to manage through the SlickNode API or even the external system. Then write your own resolver and add content here. You can also, like, to simplify that even more, let's say we want to build SpaceX content. Let's say we have our SlickNode, the SpaceX API, and we want to add a comment functionality on the which entity on the launches. What's the type called here? Let's figure this out. On the rockets. Let's say you want to have comment functionality on the rockets. So what we look at here, we have the ID, the rockets. Let's say you want to be able to here somehow load comments and then have a list of comments that people can comment on the external API. We can't change the SpaceX API, which is unfortunate, but we can, with SlickNode, we can just extend the schema here. So let's create a new module. Or we can put that in the, let's put that in the blog post here. Let's create a new type, blog, minute rocket comment. Then it implements node because we want to persist it to the database. And then it has a text of type string, it has an author of type user, and then it has created at datetime, last updated at datetime, and then we implement the timestamp interface. Okay, so now we have our comment here. Now we need to create a relationship between the comment, and we need to know like what rocket this comment is for. So let's find a field here. Let's say we're using the ID here, right? Let's say we want to write comments for this ID, and then we add this field rocket ID of type string, and there we go. Let's deploy this. Slick node deploy. Okay. Deploy the changes. All right. So now we have our rocket comment system. I just copied the. Let me reload this here. Log rocket comment. So now we can create comments for our rocket here. So like author, me, nice rocket, and here I'm just going to paste the rocket ID. Okay, so now we have a rocket comment, but we still don't have that field on our rocket element where we can load our rockets. And now what we need to do is like we don't have access to that SpaceX API, but what you can do, you can extend the types in other modules. Let's say we use extend type, and then we need the type name of that. Where is it? Damn, I lost that.
Second one over.
Oh, this one here.
That one more. That way.
Here.
That more. There you go. I'm just kidding. That was it.
Hold on. I think this is here. Oh wait, no. It's here. Use rocket comment. Let's just go to the playground here. So here we have our rockets, and this returns. What's the type name? SpaceX. Where are the rockets? Yeah, SpaceX rocket. Could have guessed that. Okay. Extend X. So now we're extending this type, and we add field comments. So now we have to add the namespace to the field because we're extending a field in a different module to like not have any name collisions. We have our blog comments, and then here we return a list of rocket comment. Now we need to tell SlickNode how to load those, and SlickNode provides a directive for that. It's the relation directive, and then here we specify the path for how to load those comments. So here we can connect the fields of those types to define how the comments are supposed to be loaded. So we have our SpaceX rocket, we have the ID, and this is supposed to be equal to the rocket ID of the blog rocket comment. There's also documentation in the SlickNode documentation, like how to create those paths. But this way we tell it like how it should connect those types. And now let's pray that this all works. Source field applications.
I know it says rocket ID dot blog. Is it going to be blog rocket comment dot rocket ID?
Let's see.
Bath, sorry, pointing up there doesn't help. SpaceX rocket dot ID equals to blog rocket comment dot ID or dot rocket ID. Yeah.
Well, it's like
Oh, yeah.
it always connects those types here because you can build like longer paths, like where you add another leg here to it. I'm not sure why this is not working at the moment. I should have tested that before. Yeah, but this is how you. Yeah, I'll have to work on that. I'm sorry, but this is how you connect the types in principle. Yeah, there might be like one issue with the external thing here, the validation logic. But yeah, this is how you create the connections, and then you can connect those GraphQL servers. Yeah, sorry about the. I need to figure that out here. I don't know, on top of my head here. Yeah, but that way, so SlickNode gives you like a really flexible way to combine different data sources, while also it gives you like a ton out of the box. You have like a lot of modules. You have like an image module, like all the fundamentals. You can use interfaces. You can use types. You can create relations between those objects, one to n, n to m, one to many. This is all out of the box, so you're really fast with spinning up backends, and then have like a serverless backend that can scale, and you can also have then like if you have like a bigger deployment, like you can set up a dedicated infrastructure in the cloud, like where you have your own Aurora database, like without noisy neighbors, and then can like just like throw traffic at it. And this all runs like with the Aurora serverless database, which scales automatically up and down, also down to 0 if you need it. So yeah, this is SlickNode for you.
Thank you.
Yeah.
Any questions?
Thanks. The deployment and use of SlickNode, like for your own projects, you were saying that it's built on like Aurora, which is like a scalable serverless architecture. Is that like an instance of AWS on your own local hardware somewhere?
On the local hardware, like I thought about this a lot. Like, do I do this locally? But the problem with like having a local deployment is you can't have like all this image solution, for example, like with the resize logic, like on your local machine, because it's like an extensive setup. And like, if like the goal with SlickNode was that you can spin up a backend in a few seconds, and you can't really do that if you have like a local deployment. Like if you're new to a project, you usually like spend like a few hours like putting everything together, like connecting a database, handling the credentials, etc. So like the fastest way is actually like to have that hosted solution where you can just run a deployment and it does like all the infrastructure stuff for it. But you can like for your own personal projects, like there's a test version which is free, where you can just play with it, try it out. It's rate limited, so that you can't throw huge amounts of traffic at it. But yeah, just try it out, and if you need anything more, just like yeah, follow us on Twitter. It's at SlickNode, or join the Slack channel. Just like just play with it, and I would love to hear your feedback, like what you want to do with it. If you run into an issue, like a use case that's not possible, I'm happy to add stuff. Like I work with a few customers together. Like one, I built like a multi-tenant SaaS application where I built like the entire backend in the morning, like including the briefing, and like with all the authorization logic and stuff. Usually it sit there like for a few weeks or months, and that made it really easy. And yeah, I also eat my own dog food. So like the whole platform you see in the in the backend here in the console, like everything is like also the SlickNode query engine. So like I went through all the like the usual stuff when you develop new system. Already did that. I've been running in production for like a year now. I'm pretty happy with the uptime and like the bugs. Like I'm at the point now like where something is not working. I assume not that the system is broken, but that I made an error. So it's like it's pretty stable. Yeah, just try it out, and if you run into anything, then yeah, let me know, and I'm happy to help you out. Or if your company is adopting GraphQL, I'm also happy to help out if you need some advice there, like how to implement that. I'll be available for that too. And yeah, thanks everyone for coming out.
Thank you.
Thank you.
Hope you learned
That's awesome. Quick question. What kind of topics would y'all be interested in seeing in another meetup? Any like trending, cool things coming out? We can always find instructors that are experts in different things, so. All right, you know everything else except for GraphQL. That's amazing.
I'd like to see an intro to React.
Intro to React, cool.
I was gonna say React Native.
We've done both of those things, yeah, definitely. Pretty much any one of our instructors can teach React. React Native, about half of them know. We already have a React Native workshop built out, a 2-hour, like, here's an intro to React Native. So I'll make an announcement on Meetup in the next week about what the next topic will be, but I'd love to see some familiar faces. Since we do a different topic every month, it seems like it's a whole new crop of people each month because it brings in different interests. But yeah, please keep coming back. I'll look at React Native if I can find somebody who's willing to do that. Again, if y'all know anybody who likes instructing or anybody who's trying to get into web development, we're a great school to get started as a true beginner. So any developers with friends that are like, what is development? How do you get started? You can send them our way. That would be amazing. Or if you know anybody who's really good at instructing, our classes are part-time. So developers that work during the day and then have some time twice a week at night can be instructors. So thank you very much for coming tonight. I hope we can see you the next month.
Thanks for coming on. If anyone wants a card here, I got a business card.
Thank you, Pete. Very impressive. Good luck with the kids. It's such a good feeling when you're on the Lambda. I had a production stuff I worked on Lambda, and it's just, you don't worry about anything with skills. So the only thing to worry about is pre-warmed concurrency. And they have now this reserve concurrency, but they're basically paying for it.
Yeah.
So I actually go to service to deal with that, where it's on lambdawarmer.com, and all it does is like every so minutes, 4 minutes or whatever, it'll actually spin up a bunch of servers that concurrently will ping however many concurrent ones you want. And so you only pay for that one hit, but it keeps your concurrency alive for that whole time, so you never have to worry about cold states.
Okay. I mean, with Signal, I have like separation by 10, and also like right now, like up to this point, I've been running on Kubernetes, and there was like significant amount more babysitting than Lambda,
Yeah.
and especially like the deployments that were slow. Like you can't really do that speed of like iteration with the Kubernetes setup, like
Right.
for a container to like start up and.
Oh yeah, Lambda, you just upload your zip with the CLI and you're done. I mean, it's.
Yeah, and I have like the management unit that like does all the infrastructure migrations and setup and stuff. So I actually launched it like 2 hours ago. I'm surprised like nothing more broke, but it's.
Yeah, just make sure you set up the Lambda alarms though too. They have really good alarms you set up on the CloudWatch logs. Or CloudWatch events, you can look for errors in your Lambda logs. It'll actually scan all your Lambda logs for errors and email you, or you can SMS topics, it'll email you when it's when those have happened. And that's when you're going into Lambda, because there's stuff you're not going to think about with Lambda, and this will help catch it for you.
Yeah, awesome. Yeah,
Hey, good luck, Rod. It's very impressive. I've got your card. Thank you.
awesome. Yeah, cool. Thanks for coming out.
Yeah, this was a really informative, and I'm pretty impressed with like the whole thing. When did you start this? When did you start building Stick Node? When did the idea to create am I describing this right? Like SlickNode is a development platform where you like, it's a development platform where you use a much more simplified version of pre-existing languages to spin up basically more than just a server, kind of just like your own platform.
Yeah.
Yeah, so I don't know. I guess I didn't realize I was asking such a big question.
No, like all years I'm like, yeah, please do. Could you do that today?
Yeah. But yeah, like, what was in like quick spiel? What was your start to finish? Like, where are y'all now, and where did this come from?
I guess it came from mostly because I got bored. Like I've been developing software a lot. Like I've done like from startups. Like I started one startup in Germany where I did like a lot of technology, and we sold it to a media company, and then like I developed for like other startups, and I worked in like on some big enterprise projects, but it was basically always the same. Like you create the controllers, the models, the data fetching, the APIs, and I thought like there must be a better way. And then like when React came about, I was like, this is a technology that's going to gain traction, and proved me right. Like it's gaining traction massively, and I was like, this technology is awesome, where you can automate a lot of this stuff, while also like I've developed like CMSs before, but there was like never really a technology with like such an interface that can gain like such traction, and which also has the flexibility that you can extend it. There's like hundreds of CMSs out there, but none of them you can extend like you can SlickNode. I'm not aware of one like that ease and like the deployment. So that's what I want. I want to have a system which like doesn't limit you, but which automates like all the stuff that I hate doing. So I just I started with SlickNode, I don't know, like 3 years ago, and then like it got way bigger than I thought. Like I did a bunch of iteration. Like first I started with the.
Is this all you? No, you have developers underneath you, and you have.
This is me.
This is all you?
Yeah.
You're just like on the weekends, wake up in the morning.
Not just
Yeah.
weekends. This is
Yeah,
yeah.
this, I'm doing that like, yeah,
That's
full
wild.
time now. But
Yeah, major kudos.
no, I think so.
No, it's very useful.
Yeah, so where I want to take it now is like, yeah, I just launched like the serverless platform. There was like a major thing that customers were complaining about. So like the price point for like small projects was too high, like for hobby projects, $50 a month. It's doable, but like
It's not software standard.
yeah, it's not software standard. So like I want to bring that price point down, and like with the serverless platform I can do that because I don't have to run my container.
Yeah.
And then I also have like with this Lambda, like this serverless deployment, I can just spin up an entire cluster for like enterprise customers. Okay, so like you want to run this like for your million user mobile application, no problem. You get your dedicated cluster. You have like a Aurora serverless instance which automatically scales up to 384 cores, and you don't have to worry about it. And yeah, so those were the things that I was solving like in the past 2 months. I launched it like 2 hours ago, and like now it's to get the word out, like have people use it. And,
Yeah. Yeah. Well, my kind of question was, and my kind of question was, is like, how do I build on top of this? Like, what I kind of understand this to be is a database management platform that has a simple UI to interact with schema, basically through forms. But then let's say I want to like create a social media website where I do write a blog post and I abstract a lot of your UI away, and I just want to plug my UI into it.
That's the thing. Is
I guess what you've done is you've provided server code through that CLI. Yeah, I guess, and then you can run that server wherever you want. But what if I want to run my server on your system? How does that work?
yeah, so how it works is you get basically have like all the system, and then you get a GraphQL endpoint, which is just the HTTP endpoint where you can send your GraphQL request. And then you can build anything you want on top. It can be like a mobile application, and inside of React Native or React application or whatever it may be, you can use like all the tools that a GraphQL system provides, like GraphQL client, like Apollo client is like a really popular one, or Signal is also compatible with Relay. So like you can use those clients and then super easily build a React backend, and you don't have to worry React front end, and you have that backend out of the box. You don't have to worry about that.
Okay. So does that mean it's hosted on your school? Still a little confused.
Yeah, so it's hosted by Signal.
There's so much
The shared, there's a shared cluster where the customer projects are hosted for those
Can you
small
like
projects.
SSH into it or something like that?
No,
No?
no, you can't SSH into it. It's like a managed platform, and you don't need to,
Okay.
because you have like this managed GraphQL endpoint. Like I don't want to give, like I made the clear rule. Like I don't run customer code inside of the cloud, like for security.
Oh, I thought you do, yeah.
No, I run I run the schema and like do my own migrations, but I don't run customer code.
Right.
What you can do then, you
It's
can
CMS, that's supposed to be CMS.
a CMS, which is part of it, but more than a CMS. Like CMS usually I understand is like you create content, you publish it, and then people read it. But like you have that interactive channel where like people can actually like sign in, and then they have permissions, and then they have rules. Like try to do that with the CMS. Like it's So like you have that channel where you can actually build interactive applications, which is not possible in the CMS usually. And you can like integrate it with your existing APIs and GraphQL endpoints, etc.
It's a behemoth. That's cool.
And only 3 years.
Yeah.
Only us was rough at times.
Thank you very much. I'm gonna head out, but
I'm glad you asked all the questions. I'm like, I have questions, I don't know how to formulate. I'm just staring at every card.
Yeah, sure.
No, but thank you so much, this is awesome. I'm excited for what else you're gonna do. And you said it's just you by yourself, you don't have anybody on your team?
At the moment, yeah. So plan is now to like get the word out,
Yeah.
and then hope that a lot of people use it, and then see where it takes from there. Like, either bootstrap it or raise funding. Or
You should just start dropping your Slack, like just in like a random place, just like throw it on Reddit, be like, hey guys, this is really cool, check it out.
yeah, this is I'm gonna do that. Like I actually haven't done like a major like announcement release on the serverless platform, so you're like the first ones to like try.